Hello everyone and welcome to this lesson. Today we will be looking at solving linear inequalities in one variable. Okay, so let's begin. Let X be a number of students attending a class. If there are 100 students, then we say that X equals 100. It means that X has only one answer. In other words, X equals 100, we call it equality. Okay? But then, if there are less than 100 students, then we say that X is less than 100. And we call this inequality. Okay? It means that it has many answers. Look, X can take on integer values ranging from 0 to 99 inclusive. Okay? Now, why do we say integer values? Because actually we are talking about students. Students cannot be fractions, so that's why we say integer values. And these integer values cannot be negatives. This is because also a student cannot be a negative, so that's why we say that it will be the integer values ranging from 0 to 99 inclusive. Okay, now for a linear inequality in a variable, all values that satisfy the inequality are called solutions of the inequality. In other words, these are answers that make the inequality true. Let's take an example. We have got X is greater than negative 2. So what are the solutions of this inequality? Now, the solutions are the real numbers more than negative 2. Some solutions are negative 1, 0, 1.5, and many others. Because these solutions are so many, we cannot write and finish them. That's why we use a number line. Now, since the solutions are any real numbers that are more than negative 2, it implies that negative 2 is not included among the solutions. So for that case, we use an open circle and then we move to the right. So we use a number line to show the solutions of the inequality because we cannot write and finish them because they are many. Okay, let's look at another inequality. This time we have X is more than or equal to negative 2. What does it mean? What are the solutions? The solutions are the real numbers more than or equal to negative 2. Some solutions are negative 2, negative 1, 0, 1.5, and many others. So you can see that for this case, negative 2 is inclusive. Okay? Now, also we note that the solutions are so many, we cannot write and finish them. For that case, we will use a number line. And remember 2 is included. So then we will use a closed circle. I hope this is understood. We'll look at another example. We have X is less than negative 2. So the solutions are the real numbers less than negative 2. Some solutions are negative 3, negative 4, negative 5.3, and many others. So any real number that is less than negative 2 will make this inequality true. And because there are so many, we cannot write and finish them. We can show them using a number line. Remember, this is less than. It implies that -2 is not included. So then we will use an open circle and then we go to the left. Okay? We look at another one. We have x is less than or equal to -2. Now, when we say less than or equal, it implies that -2 is included. Now, the solutions are the real numbers less than or equal to -2. Some of them are -2, -3, -4, -5.3, and many others. So let us use a number line to show these solutions. Okay? Remember, we are having less than or equal to -2. This means that -2 is included. So then we will use a closed circle and then we move to the left. Okay? We look at the final example. We have -2 is not equal, we have x is not equal to -2. X is not equal to -2. This actually means that the solutions are all real numbers that are not equal to -2. So it means that all real numbers make this inequality true apart from -2. So we show it on the number line. So because remember, we do not include -2, so we have to use an open circle. Then we go to the left and to the right. Okay? I hope this is really understood. Now, let us show some examples. Okay. But before we look at these examples, what do you think? Which of the following is not an equality and why? Think about that and then you can tell me your thoughts in the comments section. Now we begin our solutions. Look at x. 3x is less than 27. So we have it as 3x. So we will divide by 3 on both sides. So that we have x is less than 9. And we can show this on the number line. So we use an open circle and then we move to the left. So this implies that the solutions of the inequality 3x is less than 27 are the real numbers less than 9. Okay? We look at this example. We have -2x is more than or equal to 4. So we'll divide on both sides by -2. But dividing by a negative integer, remember, it will reverse the inequality. So that's why we will have, instead of having more than or equal to, we are having less than or equal to, because we are dividing on both sides by a negative. Okay? So then we have x is less than or equal to -2. And because we know that the solutions are so many, we can show this on the number line. Since we are using less than or equal to, then we will use a closed circle. Okay? So therefore, the solutions of the inequality negative 2x is more than 4 are the real numbers less than or equal to negative 2. Let's look at the final example. Where x is not equal to 8. Remember, the solutions to this inequality are all real numbers that are not equal to negative 8. And on the number line, we will use an open circle, then we go to the right and we go to the left. Okay? So, the solutions of the inequality x is not equal to 8 are the real numbers not equal to negative 8. I believe that you have really understood this part. Okay? Now, I want you to pause the video and do some practice. Solve each of the following inequalities and illustrate the solutions on their number line. Thank you and have a good day.